All right, so let's get going on 8.4. It's a math lab. It's using technology to graph reciprocals of quadratic functions. So we were graphing reciprocals of linear functions, and that wasn't too bad. Quadratic functions have the same idea, so I think you'll be okay with graphing quadratics as long as you can graph a parabola. So in the getting started, it says determine the x-intercepts of the graph of each quadratic function if they exist. So let's give ourselves a little bit more room. And if you can visualize these graphs in your head, that would be best. If not, we will just quickly sketch them so we could tell what the graphs would look like. All right, so starting with the first equation, it's y equals x squared minus 9. So that would be that would be a graph that looks like that. Let's try that again. You know what I'm going to do? We will make life easier. Oh boy. There we go. I'll give myself little axes for each of them. Okay, there we go. So the first equation, y equals x squared minus 9, would have a y-intercept at negative 9. So you could sketch that. It would have a y-intercept at negative 9. It's positive, so it would look something like that. And if you can visualize y equals 0, what would the x-intercepts be? Two different ways to think of it. You could solve by putting the 9 to the other side and then square root. Or you could see that x squared minus 9 is a difference of squares and solve it that way. However, either way, hopefully you get that your x-intercepts would be 3 or negative 3. All right, the second graph, I have y equals 2x minus 1 times x plus 4. So remember again, you're thinking what will make y 0? And this time I've got two factors that are already done for me. So in this one, it's negative 4 would be the x-intercept. This one, you would be solving for 0. So you'd be solving 2x minus 1 is 0. Put the 1 to the other side. And then you would divide by 2. So that one would be 1/2. That would be your x-intercept. If you can quickly FOIL in your head, you could hopefully see that your y-intercept would be negative 4, and the parabola will look something like that. Third equation, y equals x minus 1 squared. You only have one intercept. It's at 1, because 1 is the only thing that will make that equation 0. Next. If you can FOIL in your head, you would see that your y-intercept is 1, and this is one of those parabolas that touches the x-axis and bounces back off. Y equals x squared plus 9. Well, if you look at your y-intercept, it's 9. The parabola goes up, so it's going to look something like this. So there are no x-intercepts on the last one. Okay? All right, next page. Okay, so this page is talking about graphing calculator software. You're not using a graphing calculator, but what I'm going to do is I'm going to show you which each of these look like, and then you can tell, you can go through the graphs and have a look. So you should be on page 668. Oh, I know what to do now. Tell it not to do again. All right, so you should be on page 668, and it starts with parabola, and then it's reciprocal. Okay, so this is the one that's done for you on the top of page 668. Starts with the function y equals x squared plus 4, and then the reciprocal. So the value of q, it says 4. What does it mean by the value of q? Well, remember that when you write a parabola, it can be in the form of, oh boy, let's go over here, y equals a x minus p squared plus q. And remember that, let's get rid of this here. Remember that your vertex is PQ. Okay, so when it's asking for the value of Q, it's asking for the y part of your vertex. So because this is in the form of x squared plus 4, here's your y-intercept right away, and the y part of your vertex. So there on the graph, they're showing that it's crossing your y-axis at 4. It's x squared, so it's going to go up. Okay. Now look at the the reciprocal. Y equals 1, x squared plus 4. It's this little bump here that just rises. Okay. I know it looks really weird, but on the bottom, by the way, it's showing that you really aren't going to have any asymptotes because there's nothing that you can plug into x here that will make your bottom 0. Okay? If you plug in 0, you're still going to get 1/4. If you plug in anything positive, like for example a 1, you're just going to get more positive. If you plug in a negative, well, the squared's going to take care of that. So there's nothing that you can plug in on the bottom that will make the bottom 0. Therefore, you have no vertical asymptotes. You've just got that horizontal asymptote right there on your x-axis of 0. And so this weird little bump comes from finding the reciprocal of the point you know. So because my Q was 4, my reciprocal is going to have an ordered pair of 1/4 because that's the number 4 flipped, okay? So it's going to ride the x-axis. It's just going to flare up tiny bit at 1/4 and then it's going to go back out because you have an x-axis asymptote, okay? It's always in the same part of the graph. So because my original's above, so will be my asymptote, okay? Now, on your book, it says the x-intercepts of the quadratic function. Well, it had no x-intercepts. It doesn't cross the x-axis. Therefore, it says none. Number of vertical asymptotes, none, because there's nothing that makes the denominator 0. Equations of vertical asymptotes, well, none, because nothing will make the denominator 0. Okay, so that one's already done for you, but I thought I would just go through it with you. All right, so in the next line, how about we start with something like... let's get my pen going here. Y equals x squared plus 1 and y equals 1 over x squared plus 1. Okay, so we'll start with that. You've got a blank in your graph, and we'll start with that. So what would the value of q be? Well, remember, it's in the form of y equals a x minus p squared plus q. And this graph will look like y equals 1 x plus 0 squared plus 1. So the value of q is 1. So fill that in on the table under value of q. Okay, we've got two graphs to sketch. Okay, so the first equation, let's change my pen color here. Y equals x squared plus 1. We'll go through the y-axis at 1. It opens upwards, and it will go over 1, up 1, over and back 1, up 1. It would go over 2, up 4, etc. So it's just that basic parabola that looks like this. So that's this part here. And then let's say in blue, I'm going to graph my reciprocal. Well, remember, it says x-intercepts of quadratic function. There's none. It doesn't cross the x-axis. Okay. And then it says number of vertical asymptotes of the reciprocal function. So again, you look at the denominator and you ask yourself, what would make my denominator 0? And this example is the same as the one before. There was nothing that would make my denominator 0. Nothing. So number of vertical asymptotes, there are no vertical asymptotes, so there can't be any equations. Okay, so again, this is going to be like the one before. It's going to ride the x-axis, it's going to flare up, and then it's going to ride the x-axis again. Well, how far does it flare up? How high does it flare up? So the last question, because the y-intercept was 4, it rose up to 1/4. This one, the y-intercept is 1, so when you flip 1, you still get 1. So that's the only part that the reciprocal is going to rise up. So it's going to ride your x-axis. It's going to go up where 1 over 1 exists, and then it's going to go back down. So this graph, it actually shares a point at 1 and 1. Okay? Let's try another example. Okay, below. Let's see. I'll erase this and we'll do another one. Underneath, let's try the equations y equals x squared and y equals 1 over x squared. So value of q, it would be back here. There's nothing there, so the value of q is 0. We're going to sketch the original, and then we're going to sketch its reciprocal. Let me give myself a bigger axis this time. There we go. Oh, man. Okay. So in red, we will graph y equals x squared. Has a y-intercept of 0, 1 over 1, 2, 4, 3, 9, so it looks like this. So there's y equals x squared. All right, it says number of x-intercepts of the quadratic function. It actually has one x-intercept right here. It crosses at 0. So the x-intercept is 0. Okay. And then it asks number of vertical asymptotes. Okay, so look at your reciprocal. What would make the bottom 0? The only thing that would make the denominator is 0. So we actually have a vertical asymptote. There's 1, and it's where x equals 0. So we're actually going to have a vertical asymptote this time. Draw it here. We have a vertical asymptote. It's at x is 0. And now, where am I going to draw my reciprocal? So red is my original. Blues, let's go green. Green is going to be my reciprocal. Okay? So here is my vertical asymptote. I've got a horizontal asymptote at x is 0. Think back to where, when we were doing linear functions, that hopefully you remember that the reciprocal and the original always crossed each other, and they always crossed each other where y was 1. Okay, they also crossed each other where y was -1, but in this example we don't have the original graph below the x-axis, so it's not applicable there. So go to your original and put a point, a dot where y is 1, and you're going to have to do it over there as well, where y is 1. And then, just like we did in linear functions, it's going to ride the x-axis, sorry, the y-axis, or the asymptote. It's going to ride, it's going to flare out at 1, and then it's going to ride the x-axis. Same thing, vertical asymptote, go through, oh boy, pretend it went through there, okay? Pretend it went through that point of y is 1 and out that way. All right, so original and reciprocal crosses where y is 1. All right, we're going to try another example, and this time we're going to use negative values. So you're going in the graph below, you should be in the 4th row now. And we will do something simple. We'll do y equals x squared minus 1 and y equals 1 over x squared minus 1. All right, value of q, -1. Okay, so if we were to graph y equals x squared minus 1, I'll do it in red. We're going to cross my y-axis at -1. Can you tell what the x-intercepts are? Hopefully, you thought they're at -1 and 1. Okay, 2 ways to do it. Difference of squares, factor it. Put the 1 to the other side because y would be 0 when you're solving for your x-intercepts. And you would square root both sides. So y equals x squared minus 1. Something like this. Okay. All right, x-intercepts of the quadratic function. There's 2 of them. Where x is either X is either 1 or negative 1. All right, so remember linear functions. Where the original crosses the x-axis, you have asymptotes. So let's draw them. We have an asymptote at x equals negative 1. We have an asymptote right here where x is 1. Okay, now, so number of vertical asymptotes, 2, because we have two x-intercepts. The equations of the vertical asymptote, x is 1, x is negative 1. Okay, let's draw where y is 1. I already have where y is negative 1. So the rules are that it crosses the original where y is 1. So there's the original, where y is 1. It also crosses where y is negative 1. Okay? It always crosses the original, so it's going to ride the vertical asymptote, flare out where y is 1, and go back out, down, and out. And because this time, remember this isn't an absolute value. This is a reciprocal. We can have parts below the x-axis. And this is the one part below the x-axis that they share. So you're going to ride the asymptote. It's going to touch at negative 1, and then it's going to go back down. So the purple part is the reciprocal. Okay? So the rules are always the same. Draw your original, find out where your original cross is, your x-axis. Those are your vertical asymptotes. Find where y is 1 and negative 1. Those are the points that the original and the reciprocal share. We'll do one more. You have one more line. So we're going to try one more example. And we'll just do something very similar. We will do x squared minus 4. Very, very similar. Y equals 1 over x squared minus 4. Okay. My original graph. Q is negative 4, meaning I'm going through the y-axis at negative 4. Can you tell what the x-intercepts are? Hopefully you thought 2 and negative 2. Here's y equals x squared minus 4. Number of x-intercepts, 2. Number of vertical asymptotes has to be 2. Where are they? They're at x is 2 and x is negative 2. Draw them. Vertical asymptote here, vertical asymptote there. Okay, where y is 1, where y is negative 1. Go to your original. Oops, I need to do that. Let's try this again. Green. Okay, go where y is 1 on your original. On your original. Okay, ride. Go through 1. Go on your horizontal asymptote. Hug the vertical asymptote. Go through that point, and then ride your x-axis. Okay, what do we do below? Go to where the original crosses at 1 and 1, negative 1, sorry. And then it's going to this point here at negative 4. When you flip it, you get negative 1/4. So that's another part of my reciprocal. So it's going to ride the asymptote, go through that pair at negative 1/4, and then come back out. So the green is my reciprocal. And then there's some questions in your book. I'll let you answer those. Compare your results with your classmates, yada, yada, yada. Okay, you can skip that part or you can talk about it if you want. Okay? And then on page 669 starts saying, well, what if we have some negative graphs? Okay, so we'll do 3. We'll do 3 examples of negative graphs. Okay, we did all positives, so let's do some negatives. Let's look at y. How do you do that? To get y, erase that, y equals negative x squared. Get a pen going, that will be handy. Y equals negative x squared plus 1. and its reciprocal. Value of q is 1. Y equals negative x squared plus 1. Let's draw it in red. Okay. Y-intercept of 1 goes downwards. My a is negative 1. My intercepts 1, negative 1, and this time it goes down. X-intercept 1 and negative 1. Number of vertical asymptotes. If it crosses twice, I have 2 vertical asymptotes. Where are they? They're at 1. And negative 1. So let's draw the reciprocal graph. Think about the points that they share. They share where x is 1 and where y is 1 and where y is negative 1. So they're going to share the point where y is 1. That's the only point that they share. So it's going to ride the asymptote, go down at 1, and go back up. They're going to share where y is negative 1. When I so it's going to look like that. No, it's not. Erase that last one. It's not going to look like that. Silly. It's going to go over here. It's going to cross my original. I was thinking that doesn't look very right. There you go. It's going to cross my original. Ride out. Ride and out. There you go. All right, negative x squared plus 1. How about just plain old y equals negative x squared? Two more. We're done. It's reciprocal. Value of q would be 0. Okay. Y equals negative x squared. Crosses at 0, opens downwards. So it looks like this. Okay. X-intercept, just at 0. Just here, so I only have one vertical asymptote. Here, your vertical asymptote is always where the original crosses or touches the x-axis. Okay, number of vertical asymptotes 1, your x is 0. Okay, nothing's going on up here, so my reciprocal won't be up there either. My reciprocal is going to be down here. They're going to share the point where y is negative 1. Go there, go there. Hug the asymptote, flare out at negative 1, hug the asymptote, same thing on the other side. And that's your reciprocal. Okay, so it looks like that. And the very last one, because I think I've covered almost every single kind of graph you can have. The very last graph, we will do y equals negative x squared minus 4. And it's reciprocal. I'm going to erase, hold on, I'm going to erase that one, not the one, yeah. Just 1 over negative x squared minus 4. What's the value of q? It's negative 4. Okay, my graph, I'm starting at negative 4. My a is negative, so I'm just going downwards. So there is y equals negative x squared minus 4. How many times does it cross the x-intercept? The x-axis? It doesn't. Therefore, I have no vertical asymptotes, and I won't have an equation. All right, so I have no asymptotes other than my x-axis. What is my reciprocal going to look like? Well, it has to hug the axis. Where is it going to flare out? It's going to flare out at one tiny point. This flipped, negative 1/4. So it's going to ride the axis, flare out at negative 1/4, and then go back down. Just a tiny little bump, just like that one we did before. And I think I've covered every single type of equation that you can have. And then there's some questions if you want to compare classmates with your answers with your classmates. You're welcome to do that. Okay. See you in class.